So in the previous video, we created our first VHDL code, fixed some errors, compiled it. There's just a continuation of it. So looking at some useful tools for analyzing your circuit to make sure it's working. A good tool is the netlist viewer. So if you select tools, go to RTL viewer or netlist viewer, select RTL viewer, then you see how the switch actually connects to the LEDs. That's what our VHDL circuit is implementing for us now. However, you find this tool very useful as the code gets more complex. You get to see how things are connected at the register transfer level or at the gate level, and this usually gives you a pretty much a good idea. And it's also a good thing to have a snapshot of and put in your logbook as well. So let's see, let's say if we want to view the vector waveform, you can go to File, New, or just use the new icon on here. Then for the verification and debugging, you see the University Program Vector Waveform there, VWF. Double click that or press OK. In the space here, double click and you should get this pop-up window. Go to Node Finder to find the nodes that you want. On here you can list the nodes that was used in your design. I'll select the whole bus, but you can select individual ones. Just be as creative as you want. I'll put a switch on top, so switches go first, then the LEDs or the outputs on there. You can remove the components as you wish. So okay, and to run the simulation we need to give it some sort of input as a stimuli. I will select clock for now, though it's very small, but the one with the C or clock input, you can change how many times the incrementation there or what nanosecond the clock should change on there. Select OK. So you have your clock generating all the input stimuli for you. As it stands now, we have not simulated, so the output is 0. But if you go to simulate, run functional simulation, press yes, save your simulation file. Then you get a report being generated that your simulator is running. You have your output there. And as it stands now, we're just connecting the input directly to the output. On a good thing, if you can't see it clearly and you drag this bar along, there is a bar there. I'm not sure if I'll be able to do it with my tiny window, but should be fine. Yep, you got it now. So if you leave it on any particular timeline, the actual values for each of the bits is given on this side. You can change the radix if you want. If you want the radix to be hexadecimal, which is easy to read, you can have the radix in hexadecimal for both of them, or you can have one unsigned or signed as you want, and it give you the actual values. So on here you can actually compare for each bit the way the output responds to the input of that particular bit. You can go to edit and set end time, but because this is the simulation output, you won't necessarily see it there. But if you close it, and imagine the simulation length is too long, you go to set end time, and let's say you can choose nanosecond and set it to 10,000.